in this one, guys, we're going to find the curvature of r of t equals 2ti plus the quantity 1 minus t squared j minus 3tk at the point 2, 0, negative 3. So this, when you're evaluating it at a point, curvature at a point, you'll actually get a number. Okay? So we're not finding the curvature function. We're finding the actual numerical curvature at this point on the curve 2, 0, negative 3. So how curvy is the curve at that point? A high number would indicate more curvature than a lower, more bend, if you like, than a lower number. Okay, think about curvature. Usually the easiest formula to use involves that cross product. So let's think about that curvature formula, K for curvature. In general, K of t would be, okay, it's got to involve magnitudes, right? Because it's a number, it's a scalar. It doesn't have to be a number, it could be a function of t, but it's a scalar function, right? So do you remember it's r prime cross, I'm leaving off the of t, but it is with respect to t, cross r double prime, right? On top, magnitude, r prime cross r double prime. Then on the bottom, it's something cubed, right? And I tend to forget that 3 if I'm tired or I'm not careful, so put it in right away. You'll be the same way. And then it's what? R prime, magnitude r prime, right? Yeah? Okay. So that's the formula usually to use. There's another formula, magnitude t prime of t over magnitude r prime of t. In practice, that one can be difficult to use, except for certain exceptions. So if it turns out to be easy to take those derivatives, if it turns out to be easy to calculate t prime of t, then use that formula. So look inside the magnitude symbols. It tells you what to find. What do you need to find? R prime, first of all, right? So R prime with respect to t at first, and then as soon as we can, we're going to plug in the t value that produces this point. So we're going to have to figure that out, but we'll do that in a minute. So what's R prime of t? By the way, if I don't have the of t there, you can assume it's of whatever the parameter is, usually t. So R prime is going to be 2i minus 2tj minus 3k. And then R double prime, what's that? Okay, so negative 2j, that's it, right? Yeah, that makes it nice to find R prime cross R double prime, which is next, right? So, okay, R prime. Well, you know, to make life even it doesn't help that much in this one. But if you go ahead and evaluate this at the t value that produces this point, you won't have this value of t in here. So it helps a little bit. There's not that many values of t in here. Most of them went away, so it helps a little bit. So what value of t will produce that point? Well, think about it. It's r of t that generates points like this. This is on the curve, right? So just find the t value that generates 2 for the first coordinate by plugging into the I component. It's got to be what? 1, but check it. Make sure the other ones are generated. Otherwise, there's something wrong when you plug in t equals 1 for the second and third components. So do you get 0 for the second component when you plug in 1? Yeah. Do you get negative 3 for the third component when you plug in 1? Yeah. Okay, so that's how this point is generated on the curve represented by r of t. It's by a t value of 1. So if I go ahead and find r prime of 1, what's the only thing that changes? 2i doesn't change, right? So just plug in right here. You get minus 2j. Everybody believe that? Minus 3k. And then does r double prime change at all? No, it's already constant, so when you plug it in, it doesn't change. But sometimes that's if you have a lot of t values, sometimes that's very helpful. It cleans it up a lot, makes life a lot easier. So be aware of that little trick. So now I'm going to go ahead and find r prime of 1 cross r double prime of 1. Okay, so set it up. Set up the the pseudo matrix, I guess. So what goes in the middle? 2, -2, -3, the components of R prime of 1, right? And then across the last row, what would I put? 0, good. 0, -2, 0. So that cross product, I'm going to go across just to keep it on the screen, keep everything on the screen. So, okay, cross out the first column, and then take the 2 by 2 determinant of the numerical part that's left. What do you get if you do that? So -2 times 0 is 0. Okay, careful here. -2 times -3, but you subtract it off by definition, right? Yeah, so you got to be careful with those negatives. It's really easy to mess that up. Not that you would miss a whole lot of points if you did that, if that's the only mistake you make on the test, but you don't want to make those kind of mistakes that are preventable. Minus by definition, right? Okay, cross out middle column. What's it going to be? Does everybody see it's 0 when you take the determinant? Yeah. So minus, I'll put it in just for bookkeeping's sake. Minus 0j plus, what do we get here for the k component? Well, maybe I had to change it to minus, right? Not thinking ahead there. So 2 times -2, and then minus 0. So it should be minus, right? Minus 4. You see why? Because by definition it's plus, and this guy times this guy is a -4. Does that make sense? Everybody with me? Okay. So clean it up, and you get -6i minus 4k. So we need the magnitude of that guy, right? Magnitude R prime 1 cross R double prime of 1 turns out to be, what does that turn out to be? Square root of 36 plus 16, what is that? So root 52. So 2 root 13. Everybody with me there? So we've got the top part of the formula, right? Okay. We need magnitude of R prime, and then we need to cube it and make the fraction. So what would be the magnitude of R prime of 1 in this case? So here's, okay, so root 17. Everybody agree with that? So that would be 4, 8, and 9, yeah? Everybody good? All right, so let's do this. Let's say k then of 1 would be, okay, this top part, which we decided was 2 root 13, right? Divided by, let's make it, I like writing it as the 3/2 power on the bottom. Everybody knows the 3 comes from the formula. Where does the half come from? The root, so 17, like that? So I think that's all they wanted, right?